So over the weekend, we have seen a number of exploits being released for this CVE 2019-19781 vulnerability. That's this Citrix ADC, or sometimes also referred to as NetScaler vulnerability. I want to take the time here to go a little bit over how these exploits work. And as an example, I'll use here the first one that was released. This one was released by some group that calls itself Project Zero India. And I'm using this one because it's sort of the more straightforward and simple exploits, so it's a little bit more easy to understand. I want to point out a couple of the key features here. So first of all, the actual vulnerable script being used here is this new BM that stands for new bookmark.pl. This directory traversally is actually totally irrelevant, not required at all, and some of the more recent exploits don't actually use this. So this would work just with /vpns portal scripts newbm.pl. Next, we have some data being sent here. First parameter is URL, not really relevant here. Just any valid URL here will do. Then we have the title. That gets interesting. So this is the actual sort of payload. And then we have a description, which again here is just a test. The remaining parameter here also not really relevant as far as the exploit is concerned. The payload could actually also show up here in the description parameter. Doesn't have to be in the title. The actual vulnerability is actually related to this NSC user header. So here the exploit adds additional headers. NSC user, this is where we have the directory traversal, as you'll see in a bit. And then we have a second header, this NSC nonce header. Actually kind of irrelevant, that header. It just has to be present. That's really the important part. And yes, then we have a content type header. So the parameters are being parsed correctly. So this is the first curl request that writes a file, and we'll see in a bit how this works. Here is the file being written, and you see here this exploit creates sort of a random file name. I actually modified this a little bit from the original exploit, and then after we write this file, we have a second exploit that actually then hits the file and executes the code, and finally sort of a last curl request, and that's a little bit specific to this version of the exploit, where we then download the output of the command. But anyway, so these are these three pull requests or curl requests. So let's take a quick look at what this looks like, what code is receiving this data. And I'm going to start out with this new bm.pl script. So let me connect here to my Citrix ADC, and I'm using here the latest version, and yeah, the username is nsroot that you're using here. Now, when you connect first via SSH, you're sort of in this special shell. Just by typing shell, you end up in sort of your normal FreeBSD bash. And now let's actually first take a look at the Apache configuration and see where we find all of these scripts. So let me just search for portal. That usually works pretty well. And here we have this VPNS portal scripts. You see that these files in this directory, as long as they end in .pl, are being parsed by Perl. No additional authentication here in this case, so you can hit those files as far as Apache is concerned without any authentication. And then this particular URL is mapped to NetScaler portal scripts on the file system. So that's where we'll find these scripts. So NetScaler portal scripts. Let's take a look. So here we have our scripts here, and newbm.pl is what's sort of interesting here. So let's take a look at this. There are first a couple of sort of specific NetScaler modules that are being loaded. That's really sort of where some of the interesting stuff happens. We'll look at them quickly. But then here we have the URL, title, description, where this is being used, and this UI in use parameter. So let's see what happens with those. So here it defines this new bookmark hash with those parameters. You see very little sort of cleanup. The only thing it does here is some URL encoding of less than quotes and ampersand. So those are characters where we may have problems with, but anything else, like for example, you may have seen square brackets, and so no big problem here. Yeah, so that's essentially where this bookmark is created, and then we have a couple little checks here, but in the end what's happening is that the bookmark is then written to a file, and let me see if I can find this, and you see a couple of like scripts are sort of removed here. And then we have this document is being created, and that document is then being written using this user object. So really a lot of the interesting stuff is happening here with this user object. So where we find this is this special NetScaler module here, NetScaler portal user pref. So let's find this, and that should be in portal modules, and then we have here NetScaler portal, and then we have here these different modules, and the one I'm going to look at here is the user prefs module. So let's take a quick look at this and see what's happening here. So okay, here we first have sort of our new object here being created. What's sort of interesting here is this CSD subroutine. That's where for a lot of the more interesting things happen. For example, here we see that the username is being read from this NSC user header. The NSC user header is assigned, the value is assigned to this environment variable. That's if you have standard CGI stuff, and it has to be present. If it's not present, you get an error page. But that's sort of interesting. We actually see that the input validation for this username is commented out. On the other hand, if you look at what's being allowed here, we have dots being allowed, we have slash being allowed, backslashes at least. So it is quite open here, that username input validation. So not really sure that really would restrict it too much, but kind of interesting where they just essentially commented out saying, hey, you know, we don't really need to validate our username. And then this nonce is being read here. So here we have the nonce. It's then being unpacked here as hexadecimal, and then it just base checks this is a hexadecimal value. Like I said, this nonce isn't really used for much as far as the exploit is concerned here. It later, and you see this down here, kind of creates a session file with that nonce as a name, but since it's hexadecimal, there isn't really much we can do with that. On the other hand, we have this file name that's being defined here, and that just uses the username and then adds .xml. So there's a fixed prefix, this bookmark directory, but then we have, without any input validation, we have the username and then followed by .xml. So what this means is, here we have our directory traversal. And you saw this earlier. The NSC user header had dots in it, so that was used to basically break out of this bookmark directory into the root directory, then work your way down into a directory that we can write to. The only problem the attacker has at this point is that the extension is fixed to .xml. So that's where things get a little bit tricky as it gets to actually achieving the code execution. But on the other hand, writing files anywhere in the file system where the web server has write permission is pretty straightforward with this vulnerability, and just relies on passing the right username as part of that NSC user header. So this is how we get the file name then, and that's where we have then that file write. It just uses that file name, and this file write function is what you saw earlier in the in this new bm.pl file. So anyway, that's sort of the first part is vulnerability. The directory traverse, like I said, it's very straightforward to exploit that. The next thing we need is a file, a directory that's writable by the attacker, or by the web server, I should say, and that we can use to execute code. So that's sort of where the second part of the exploit comes in. And let me just go out quickly and take a look at this again. So the content being written into this file is here the title, template new, then block, then exec, and here this is just a parameter being passed into, and then the output is then piped to this XML file. So that's kind of what we're doing here, but the exec part is really sort of what executes it, and this block allows us then to essentially have this treated as part of a template. What they're using here on NetScaler is template language. Well, it's Perl, but I just want to compare it to, like, your classic ASP or your PHP. They essentially mix HTML with code, and in ASP, classic ASP, we'd have like a less than %. In PHP, you have a less than question mark to sort of distinguish the code from the HTML. In these Perl templates, it's essentially that square bracket that causes that to happen. So what the attacker does here, the attacker writes an XML file, and the file name will be here, this NetScaler portal templates, the file name that we created randomly, followed by .xml. So I guess I can just run this and then we'll sort of see what's happening here. Now here I need to use the IP address of my host and then a command to execute. So let's see that. Perhaps not sure if this will work all the way because I keep playing with this, but it should at least create this file for us. So let's run this the way I just have a host name defined here. Let's see if that works. And just ls as a quick command to execute. Oh yeah, and you see it worked here. We get the output back, but we should still have those files now on the system, so we can take a closer look at how this worked. And if I scroll back here quickly, so we have to look for the file in NetScaler portal templates. So let me connect back here to my system. We see there's a bunch of templates here. Turns out the extension of the template doesn't matter. Usually these templates have a .tmpl extension. Everything you see here with .xml, that was me running exploits. So that's usually you don't have any .xml files in that directory. And let me find the last one here. So this is the one I just created. Yeah, and it got now replaced with the output of the command. If you remember, the way it sort of worked was that it piped the output back to the XML file, so it kind of overrode itself there in the simple exploit. Let me see if I have some other exploit files here that still have some of that template code. Yeah, this is one that was created using the trusted security exploit. That's a remote shell. It looks a little bit more complex, but you sort of see the same pattern here. Here we have this bookmark that we wrote. The description here was empty. The title, it included that template, that script. And then we have here square bracket % that sort of starts the template part here. And then we have this sort of new template that then can be used to trigger command execution. There's a more straightforward way to execute commands with this template language, but actually they configured it to not allow that kind of execution. So the direct running Perl script inside the template didn't work, which is sort of why they use this template new block part here to actually make that that code execution work. And the trusted sec version of the exploit does use these sort of CHR obfuscation, I guess, to sort of make it pass some filters and such. But if you decode it, this is just a little Python code now to basically start the reverse shell. So that's what this is about. Now, I want to point out basically the other part that makes really this exploit possible, and that's the ability of the web server to write to these directories. I think that's sort of really one of the big shortcomings here as far as the configuration of this web server goes. You see, all of these files are not only writable by nobody, they're owned by nobody. And then also all of these files inside here, so an attacker could also overwrite some of the existing files. Lots of possibilities here. Let me just show you one of the normal files so you kind of see what some of these templates here look like. So this is like a normal template here, and you see where you have sort of this template language here being used to change some of the data here inside this particular template file. Some of them, I guess, may be written by the server here, but I didn't really run into this. I'm not that terribly familiar with this user interface to really figure out why they exactly did it this way, but this is sort of a huge problem here. Let's go back a little bit to the server configuration. And I just want to point out a couple issues with that, and we look at the location part here. So first of all, for some of these directories, the extension isn't really limited. Here where where Perl is actually executing code. So that's a partial problem here as well. Like here in this one directory, we limit it to .pl. So that's a little bit more restricted. But here, for example, is VPN as admin. It's not restricted. Now, this is actually a directory that requires some authentication. Interestingly, that's actually empty, that directory. There's nothing in there, but it's also writable by the web server. So that would be another place here to look for these themes, directories. I believe they're also writable. Let's see, var VPN themes. Yeah, that's also owned by the web server. In general, best practice, and I would say also almost minimum requirement, your web server should never have write access to any files, any directory inside the document root of the web server. So you're avoiding exactly what's happening here, where the web server is writing a file and then you're hitting the file with your web browser executing code. A very common problem, sadly, and a little bit disappointing that a system like this suffers from this issue. But if you can tell so by looking at some of the input validation that it's missing, there's a lot wrong with this appliance. and I wouldn't be surprised if there are more exploits or more vulnerabilities that people will find in this. Let me just show you another little script here. So a lot of it focuses on this new bm.pl. This pick theme script actually has a very similar problem. It creates pretty much the same XML file or similar XML file with where the user can sort of define user preferences. And here you have that theme name that you can add. Again, absolutely no real input validation here. It just uses the data and then writes it to a file. The same file write function, so the same NSC user directory traversal exploit will work here as well. So that's another function. Yeah, just want to point this out here. So here, that's where this CSD function is being called. That's where the username is being picked from the NSC user header, and then later here is where the file is being written. As a patch, and Citrix is going to release a patch in a couple of weeks, I think, 20th or something like this is when they're going to come out with an official patch for this. I hope they'll address this NSC user input validation. That would probably be sort of the minimum they should do. I hope they go a little bit beyond that and fix some of these permission issues, but that may have some dependencies I haven't really looked at in detail. What the web server actually has to write to these files. Maybe even some more authentication for some of these directories that you can't easily hit them without authentication. That may at least be sort of a partial fix here. But anyway, that's what I want to show you. Just a quick walkthrough through this vulnerability and what exactly went wrong here on the Citrix side.